Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hi Herman and Corin. So I was doing some repairs earlier this week, as you know, on the Visa mounts. The little screws that go into the back, you know, those when you have a Visa mount for mounting your monitors and they screw into something. So my ones, I noticed that there was only actually one of them left, or two left on one. The other two were gone, and I always assumed the thread was just pulled out. But I heard something rattling in the monitor, and I got to, of course, with the encouragement and help of ChatGPT, told me exactly how to prise open the monitor, which, if I can just ask one tangential question, do you guys have recommendations for a good prizing tool? It's one of those things that is surprisingly important and useful. These AOC monitors, they're so hard to get open, and I'm using like a little $1 thing from AliExpress, but I've heard that you can actually use automotive prizing tools to open up these electronics. Anyway, so I got it open after about 10 or 15 minutes of squeezing out those little locks. That was actually the hardest part. And I was looking at the back case, and I noticed that the cover is the PSU. And I was asking ChatGPT before I figured out a way to just cut through the tape and roll out the things that way. Can I just open up this box? So I thought ChatGPT was mistaking itself for thinking that the component was powered on, which it would never be. I wouldn't think about opening up disassembling an electronic while it was plugged in, but it wasn't mistaken. Its concern is actually that the capacitors in the PSU could actually hold enough charge to give a dangerous shock, and that it would take several hours and even potentially a day to be certain that the capacitors had discharged. I always thought the capacitors you had to wait like a minute or two in general, and that then you were fine. But I guess a monitor is a heavier piece of, a more powerful piece of machinery than a desktop. And looking at the design now, I noticed that the 240 volt AC goes straight in with that IEC fitting. Herman and Corin, I think it would be important for us to talk about we talked about static electricity and how risky it is to our components in a previous episode. But much more important is the risk of any kind of electricity to us, the humans repairing our stuff. If static fries board, it might be a very expensive and very frustrating moment, but it's not going to be the end of the world. Whereas an electric shock can be deadly, especially when we're talking about 240 volt or 230 volt AC current. So I'd like to ask you, Herman and Corin, for those like me who are getting into repairing their own things, and it is a very empowering feeling to be able to fix things you thought were just broken. It can also be saves a lot of money, but of course none of us want to fry ourselves in the process. I've always had the assumption when working with electronics that DC circuits are pretty safe in general. That when you as long as you take out the AC component and you press the power button, which is a good tip for people to know, to discharge anything remaining in the capacitors, that you're kind of mostly safe. We don't want to be totally overcautious or living in porcelain, because there's a lot you can do without going over the top. But what are those maybe edge cases, Herman and Corin, that people should really be aware of for their own safety? Whether it's that a large capacitor in a monitor could actually hold a dangerous level of charge, through to any other potential common pitfalls that those working with electronics or even cars should know about, not to ensure that they don't damage their components, but to make sure that they don't damage themselves in the process. Over to you two.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I am sitting here in our living room in Jerusalem with my brother. It is February 24th, 2026, and the rain is absolutely lashing against the windows today, which makes it the perfect afternoon to stay inside and talk about the guts of our gadgets.
Herman Poppleberry here.
It is a beautiful day for some technical talk, although I have to say, the topic today makes my fingers hurt just thinking about it. There is a specific kind of phantom pain you get in your fingertips when you spend too much time fighting with plastic enclosures.
Yeah, we have got a really practical but also slightly terrifying prompt today from a listener named Daniel. Daniel has been working on his monitor, specifically trying to fix the Video Electronics Standards Association mounts, or VESA mounts as most people call them. He had some loose screws rattling around inside the casing and had to pry the whole thing open to get them out before they shorted something.
The classic rattling screw. It is the international signal for a project that is about to get much more complicated than you planned. It is like a tiny metallic ticking time bomb. If that screw rolls across the wrong two traces on a logic board while the power is on, it is game over for the monitor.
Exactly. And Daniel wanted to know about two things. First, what are the best prying tools for getting into these modern electronics that seem like they were never meant to be opened? He mentioned using a cheap $1 tool and hearing that automotive tools might be better. And second, and more importantly, he wants to talk about electrical safety. Specifically, the danger of capacitors in a power supply unit holding a charge even after you have unplugged the device.
This is such a great topic because it bridges that gap between the physical frustration of repair and the actual life safety risks that people often underestimate when they are just trying to save a monitor from the landfill. We are living in an era where the right to repair movement has made some huge strides, especially with the new European Union regulations that went into full effect this year and the Oregon laws from 2024 finally hitting the retail market. But just because you have the right to open it doesn't mean the device is designed to make it easy or safe for you.
Let us start with the prying. Daniel mentioned he was using a $1 tool from an online marketplace and heard that automotive prying tools might be better. Herman, you've opened more laptops and monitors than anyone I know. What is the deal with these plastic clips? Why is it so hard to just get a clean opening?
Oh, the clips are the bane of my existence. Manufacturers have moved away from screws because clips are faster for assembly robots, and they make the device look seamless. It is called snap fit assembly. But for a human, they are a nightmare. The problem with those cheap $1 plastic spudgers, the ones that look like little blue crowbars, is that they are often made of a very soft recycled nylon. They deform or snap the second you hit a stubborn clip. You end up with a tool that has a rounded off edge, which is useless for getting into a tight seam.
So what is the upgrade? Is Daniel right about the automotive tools? I have seen those big orange kits at the hardware store.
He is partially right, but there is a major caveat. Automotive trim removal tools are fantastic for larger panels, like if you are taking apart a car dashboard, or maybe a very large 75-inch television. They are usually made of a glass-reinforced nylon which is much stiffer and has a higher tensile strength. But for a computer monitor, they can be a bit like using a sledgehammer for a finishing nail. They are often too thick to get into that initial seam between the front bezel and the back cover. If you force a thick automotive tool into a thin monitor seam, you are going to mar the plastic, or worse, crack the LCD panel itself because you are putting too much localized pressure on the edge of the glass.
So what is the surgical approach? If I want to open a monitor and have it look like it was never opened when I am done, what is in your toolkit?
You want a hierarchy of tools. You start with something called an iSesamo. It is a legendary tool in the repair community. It is a very flexible, very thin piece of spring steel with a rubberized handle. It was originally designed in Italy for opening iPods, but it is the gold standard for monitors. You use that just to find the first gap. But here is the secret, corn. You never use the metal tool to do the heavy prying. If you do, you will chew up the plastic edges of the monitor, and it will look like a dog chewed on it when you are done.
Right, because the metal is harder than the plastic. It is basic material science.
Exactly. The metal wins every time. So you use the thin metal tool to create a tiny gap, maybe just a millimeter wide, and then you jam a guitar pick or a specialized plastic opening pick in there to hold it open. I actually prefer heavy-duty guitar picks, the ones that are about 0.8 millimeters thick. Once you have a few picks in the seam to prevent it from snapping back shut, then you bring in the heavy-duty reinforced nylon spudgers. There is a tool called a halberd spudger that has a hooked end and a flat blade. That is the gold standard for monitors. You can hook it under the internal lip of the frame and pull upward to release the clip without putting pressure on the outer bezel.
It sounds like a slow process. I remember watching you open that old Dell monitor a few years ago, and it sounded like you were breaking every single internal component. That snapping sound is terrifying.
It is. That is the crack of doom. But usually it is just the plastic tab finally letting go of its slot. The trick is to apply steady, firm pressure rather than sudden jerks. If you feel like you are pushing too hard and nothing is moving, there is probably a hidden screw. Check under the rubber feet, check behind the VES mount plate itself, and check under any stickers. Manufacturers love hiding screws under stickers that say warranty void if removed. Which, by the way, for our listeners in the United States, those stickers are generally not legally enforceable under the Magnuson-Moss Warranty Act, but they are a great psychological deterrent.
Okay, so Daniel gets the monitor open. He finds his screws. But now he is looking at the internal boards. He mentioned the power supply unit and the capacitors. This is where things get serious. Most people think unplugged equals safe. Why is that a dangerous assumption?
It is probably the most dangerous assumption in DIY repair. A capacitor is essentially a temporary battery. Its entire job is to store electrical energy. In a power supply unit, specifically a switching mode power supply, which is what almost every monitor uses, you have these large electrolytic capacitors. They are the big cylindrical cans you see on the board, usually with a K or an X stamped into the top.
And their job is to smooth out the power, right? To keep the screen from flickering.
Right. They take the rectified high voltage direct current and smooth out the ripples so the rest of the electronics get a nice steady flow. The problem is that the primary filter capacitor in a monitor can be holding anywhere from 170 volts to over 380 volts depending on your local grid and the design of the power factor correction circuit. And it can hold that charge for a long, long time. We are talking about enough energy to stop a human heart or, at the very least, cause a violent involuntary muscle contraction that sends your hand flying into a sharp metal heatsink.
Daniel asked about the wait and see method. He mentioned some people say wait a few minutes, others say a day. What is the actual reality of capacitor discharge? Is there a magic number of hours?
The honest, engineer answer is never trust a timer. Most modern power supplies have something called a bleeder resistor. This is a high-value resistor placed across the capacitor terminals specifically designed to slowly drain the charge when the power is cut. If everything is working perfectly, a capacitor might be safe in a few minutes. But we are usually opening these things because something is not working perfectly.
That is the catch-22 of repair.
Exactly. If the power supply failed because that bleeder resistor burned out or a trace on the circuit board broke due to heat stress, that capacitor could stay charged at a lethal voltage for days or even weeks. I am not exaggerating. I have seen capacitors in old CRT monitors hold a significant bite months after being disconnected. In a modern flat panel monitor, the danger is usually gone after 24 hours, but you should never ever bet your life on it.
So press the power button while unplugged. Trick? Does that actually do anything? I see that advice on every forum.
It does something, but it is not a safety protocol. When you press the power button while it is unplugged, you are essentially telling the logic board to try and turn on. It will pull a tiny bit of current from the capacitors to try and boot up the processor. This can drain the secondary side of the power supply, the low voltage part that runs the 5 volt or 12 volt rails. But it often doesn't fully drain the primary high voltage side. The switching controller needs a certain threshold of voltage to even start oscillating. Once the voltage drops below that threshold, the controller stops, the circuit opens, and the remaining charge, which could still be 90 or 100 volts, just sits there with nowhere to go.
So you could press the button, the little power light blinks once and goes out, and you think, okay, it is empty, but there is still 100 volts sitting in that big cylinder.
Precisely. It is a false sense of security. It is better than doing nothing, but it is not a substitute for verification.
So how do we actually stay safe? If I am Daniel and I'm looking at this board, how do I know if I'm about to get a heart-stopping shock?
Step 1 is a multimeter. You cannot see electricity, so you have to measure it. You need a multimeter rated for at least Category 2 or Category 3 safety. You set it to high voltage direct current, and you carefully touch the probes to the two leads of the large capacitors. You usually do this from the underside of the board where the solder joints are. If it reads anything above maybe 12 volts, you should treat it as live and dangerous.
And if it is still holding a charge, how do you get rid of it without just touching it with a screwdriver and making a giant spark? Because I have seen people do that on YouTube, and it looks like a small explosion.
Please, for the love of all that is holy, do not do the screwdriver trick. Yes, it discharges the capacitor, but it is incredibly bad for the component and the person. It creates a massive current spike, essentially a short circuit that can damage the internal foil of the capacitor, it can pit your screwdriver, and the sudden electromagnetic pulse can actually fry nearby sensitive microchips on the board. You are trying to fix a VESA mount, not blow up the display controller.
Not to mention the risk of molten metal flying into your eye from the arc.
That too. The professional way to do it is with a discharge tool. You can actually make one very easily with a high wattage resistor, say 5 or 10 watts and maybe 2000 ohms, soldered to some insulated probes. You touch that to the capacitor leads, and it converts the stored energy into a tiny bit of heat over a few seconds. It is silent, safe, and doesn't damage the circuit. If you don't want to build one, you can buy commercial capacitor discharge pins for about $20.
That seems like a very specific tool for a casual DIYer to have. Is there a household version? I have heard people mention light bulbs.
An old-fashioned incandescent light bulb, not an LED or a CFL, works great. If you have a socket with two insulated wires, you can touch them to the capacitor. If the bulb glows and then fades out, you know the energy is gone. It is a great visual indicator. But again, you have to be very careful with how you handle those wires. You are dealing with high voltage.
Let us talk about the edge cases Daniel mentioned. We have talked about monitors, but what about other devices? He mentioned cars or other electronics. Are the risks different?
They are very different. Let us look at the low voltage misconception. Daniel mentioned he usually thinks direct current circuits are safe. In many cases, like a 9-volt battery or a 12-volt car accessory, that is true. It won't push enough current through your skin to hurt you because your body has high electrical resistance. But a car battery, that is 12 volts, but it can put out 800 amps. If you accidentally bridge the terminals with a wedding ring or a metal watch band, that metal will turn white hot in a fraction of a second. You won't get electrocuted in the sense of a heart stoppage, but you will get a third-degree burn or lose a finger to the heat.
Right. So safety isn't just about the shock, it is about the energy density.
Exactly. And then you have the real monsters. Daniel is working on a modern monitor, which is likely an LCD or an LED screen. But if any of our listeners are into retro gaming and are opening up old cathode ray tube monitors or televisions, that is a completely different level of danger. Those things are basically particle accelerators in a glass box.
Oh man, the old glass tubes. I remember you telling me those can hold 30,000 volts.
Yeah, 25 to 30,000 volts. And the tube itself acts like a giant capacitor. It is called the aquedag coating on the glass. Even if you remove the circuit board, the glass tube can hold a charge for weeks. If you touch the anode, that little rubber suction cup on the back of the tube, without discharging it properly to the frame ground, it can literally throw you across the room. People have actually died from CRT discharges, not necessarily from the shock itself, but from the secondary injury of being thrown into a wall or dropping the heavy glass tube on themselves.
That puts Daniel's VESA mount repair in perspective. But even in a modern monitor, there is another edge case I want to bring up. What about the backlights?
Good catch, Korn. If it is an older LCD monitor, say, from 10 or 15 years ago, that uses cold cathode fluorescent lamps for backlighting, there is an inverter board. That board takes the low voltage power and steps it up to maybe 600 or 1000 volts to strike the arc in the fluorescent tubes. Those inverters are often small and look innocent, but they can give you a very nasty high-frequency burn if you touch them while the monitor is plugged in. Even modern LED backlights can have boost converters that step 12 volts up to 60 or 80 volts. It won't kill you, but it will definitely make you jump.
So the takeaway here is that size doesn't necessarily correlate with danger. A small board can have a high voltage transformer, and a large capacitor can be hidden under a heatsink where you can't see it.
Absolutely. Another edge case is the grounded versus isolated problem. When you are working on a device, many people think that wearing an anti-static wrist strap makes them safe, but that is actually the opposite of what you want when working with high voltage.
Wait, really? We always talk about the importance of those straps to protect the components from static.
Yes, to protect the components from YOU. But if you are working on a live or charged power supply and you are wearing a strap that is tied to ground, you have just created a perfect low resistance path for electricity to flow through your arm, through your heart, and out to the ground. If you touch a live wire with your right hand and you are wearing a grounded strap on your left, the current goes right through your chest.
That is a terrifying thought. So the strap is for when the power is definitely gone and you are touching sensitive chips.
Correct. When you are dealing with the power supply side, you actually want to be isolated. Professional high voltage technicians often work with one hand in their pocket.
One hand in the pocket? Is that just to look cool while you work? Like a 1950s rebel?
Ha! No, it is a very old, very serious safety rule. If you have one hand in your pocket, you cannot accidentally touch a grounded frame with one hand while touching a live wire with the other. If you use both hands, the current goes from one arm, across your chest, right past your heart, and out the other arm. If you only use one hand, the current might go through your finger and out your foot, which is still bad, but much less likely to cause ventricular fibrillation.
That is a great insider tip. It sounds like something from a mid-century engineering manual, but it still applies today.
It really does. Physics doesn't change just because we have smaller transistors. Another thing Daniel should be aware of is dielectric absorption. This is a weird phenomenon where you discharge a capacitor, it reads 0 volts, you walk away for 10 minutes, and when you come back it has regrown, some voltage.
Oh, wait, how is that possible? Is it pulling energy from the air?
No, it is internal. The molecules in the dielectric material, the insulator between the capacitor plates, get polarized by the high voltage. When you short the capacitor, you drain the surface charge, but the soaked-in polarization in the dielectric takes time to relax. As it relaxes, it pushes some charge back onto the plates. It is usually not enough to be lethal, but it can be enough to give you a surprising zip that makes you drop your tools.
This is why you always measure twice.
Exactly. Measure, discharge, wait, and measure again.
Let us talk about the empowerment aspect Daniel mentioned. He said it feels great to fix things. I totally agree. There is something almost rebellious about fixing a monitor that the manufacturer probably wanted you to throw away and replace. But how do we balance that empowerment with the reality of the risks?
I think it comes down to respect. You have to respect the energy stored in these devices. I always tell people, if you are opening a device for the first time, find a teardown guide online. Sites like iFixit or even just YouTube videos of people repairing that specific model are invaluable. They will often point out exactly where the dangerous capacitors are. In 2026, we actually have better access to service manuals than we did 5 years ago thanks to the new laws. Use them.
And don't rush. I think most accidents happen when you're frustrated. Like when Daniel was struggling with those plastic clips. You get annoyed, you pry a little too hard, the tool slips, and your hand flies into the power supply board.
That is exactly how it happens. Physical frustration leads to safety lapses. If a clip isn't moving, stop. Take a breath. Try a different angle. Check if there is a hidden screw under a rubber foot or a sticker. And for the VESA mount specifically, Daniel should be careful about the screws he is using to put it back together.
Oh, that is a good point. Visa screws are usually M4 screws, but the length is critical.
It is vital. If you use a screw that is even 2 millimeters too long, it can go right through the internal mounting bracket and pierce the back of the LCD panel or the backlight assembly. I have seen people fix a VESA mount only to turn the monitor on and see a giant black splotch where the screw pushed into the layers of the screen. Always measure the depth of the hole before you drive a screw in.
Let us circle back to the VESA mounts specifically. Daniel was repairing them because the screws were loose. I have seen this happen where the internal metal nuts that the VESA screws go into actually break away from the plastic frame. Is that a common failure point?
Very common. Most monitors have a plastic internal skeleton. The VESA mount points are often just brass inserts pressed into that plastic. If you use a monitor arm and you are constantly moving the screen around, or if you over-tighten the screws, you put a lot of torque on those inserts. Eventually, the plastic fatigues and the insert just pops out.
So if Daniel finds that the plastic is actually cracked or the insert is loose, what is the fix? You can't just screw it back in if the hole is gone.
This is where epoxy becomes your best friend. A two-part structural epoxy, like JB Weld or a high-strength Loctite, can often rebuild that area. You clean the plastic with some 99% isopropyl alcohol, scuff it up a bit with sandpaper so the glue has something to grab onto, and then set the insert back in with a generous amount of epoxy. You have to let it cure for a full 24 hours though. Don't rush it. If you put the weight of the monitor on it before it is fully cross-linked, it will just pull right back out.
It is interesting how electronic repair often turns into mechanical engineering very quickly.
It really does, especially with monitors. They are mostly air, plastic, and tension.
Okay, let us summarize some practical takeaways for Daniel and anyone else thinking about prying open their hardware. Number 1. Get the right tools. Those thin metal opening tools like the Isosamo and reinforced nylon spudgers are a game changer. Don't use a screwdriver to pry plastic.
Number 2. Never trust a capacitor. Assume it is charged until you have measured it with a multimeter, even if it has been unplugged for a day.
Number 3. The power button trick is a good first step to drain the logic board, but it is not a guarantee of safety for the high voltage side.
Number 4. If you are working near a power supply, keep one hand in your pocket. It sounds silly, but it prevents a path through your heart.
And number 5, use your resources. Look for teardowns and service manuals before you start prying. Knowing where the clips are is half the battle.
I would add a number 6, work in a well-lit, clean area. If a tiny screw falls into a power supply and you can't find it, you cannot plug that monitor back in. That screw will eventually find a way to bridge two high voltage points, and then you will have a very expensive fire on your desk.
That is actually a great point. Daniel mentioned he was retrieving loose screws. That is a lucky break that he heard them rattling. If they had stayed wedged in there, he might have had a short circuit the next time he moved the monitor.
Exactly. Rattling is good. It is the silent loose screws that get you.
You know, we have done over 800 episodes of this show, and we keep coming back to this theme of knowing your gear. There is such a divide now between people who see electronics as magic black boxes and people who see them as repairable machines.
And that divide is often just a matter of confidence and a $5 set of prying tools. But that confidence has to be backed by knowledge. I love that Daniel is doing this. Repairing a VESA mount is a perfect gateway repair. It is mostly mechanical, but it forces you to confront the internal reality of the device.
It is also a great lesson in the cascading implications we always talk about. You want to fix a screw, so you have to open the case. To open the case, you need to understand plastic clips. Once the case is open, you have to understand electrical safety. Everything is connected.
It really is. And the more you understand those connections, the less scary the world becomes. Even if the capacitors still deserve a healthy amount of fear, or let us call it respectful caution.
I think respectful caution is the perfect term for it. Herman, do you think we are seeing a shift back toward repairability? I know we have mentioned the right to repair movement in passing before, but it feels like it is gaining some real momentum lately.
It definitely is. We are seeing legislation in the European Union and several states in the United States that are starting to mandate that manufacturers provide parts and manuals. But more importantly, I think there is a cultural shift. People are tired of the disposable culture. When you pay $500 for a nice monitor, you want it to last 10 years, not 2.
And being able to fix a silly mechanical failure like a loose VESA mount is the difference between that monitor staying on a desk or ending up in a crushing machine at a recycling center.
Exactly. And the environmental impact is huge. The embodied energy in a monitor, the energy it took to mine the materials, manufacture the panel, and ship it across the world is massive. Keeping it alive for a few more years is one of the best things you can do for the planet.
Well, I think we have covered a lot of ground here. From the specific types of nylon in a spudger to the life-saving one hand in the pocket rule. Daniel, I hope your VESA mount repair went well and that the monitor is back on its arm and solid as a rock.
And I hope you didn't get any nasty surprises from those capacitors. It really is empowering once you get that case snapped back together and everything works. It feels like you have reclaimed a bit of your own technology.
It really does. If any of you listening have had your own near-miss experiences with DIY repair, or have found a tool that changed the way you work on things, we would love to hear about it. You can always reach us at show@myweirdprompts.com.
Or you can head over to our website, myweirdprompts.com, where we have a contact form and a full archive of all our past episodes. We have covered everything from static electricity to the history of the screwdriver, so there is plenty to dig into if you are in a DIY mood.
And hey, if you have been enjoying the show and finding these deep dives helpful, we would really appreciate it if you could leave us a review on your podcast app. Whether you listen on Spotify, Apple Podcasts, or anywhere else, those ratings really help new people find the show.
It genuinely makes a difference. We see every review and we really appreciate the support from this community.
Definitely. We have a great group of curious people here, and it is always fun to explore these prompts with you all.
This has been My Weird Prompts. I am Herman Poppleberry.
And I am Corn. Thanks for listening, and stay safe out there with those capacitors.
Seriously, keep that hand in your pocket. Goodbye.
Bye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.